Good day, everyone. I hope this video finds you well as we're starting week 2 of our extended e-learning. Let's wrap up the section on circumference of circles and angles in circles. And today, the final section of that is to study the length of an arc of a circle. And an arc, remember, is only a part of the way around. So today we'd like to know, instead of finding the circumference of the entire circle, what is it to find just the length of part of that circle, such as the arc in red here from A to B? Well, the way I think of it is, remember that the measurement in degrees is the same as the measurement in degrees of the central angle. So remember that in this angle, in this diagram here, for example, if this central angle were measured as 50 degrees, this arc is also measured in 50 degrees. Now, that's not the measurement we are actually interested in today. We are interested in finding the length of the arc, let's say in meters, because the radius would be measured in maybe meters, and that means the circumference is also measured in meters. And we would want to know how many meters it is to go just around this part of the circle. So the way I think of it and the way it's presented here is just think of it as finding out what fraction of the circle that arc is and then multiplying the circumference by that fraction. So for example, let's pretend that this was, maybe let's make it where the math comes out even easier. Let's say this was 60 degrees. And this arc was 60 degrees. And then the radius, let's say the radius is 4 meters. Okay, and remember that means that the diameter is 8 meters. Right, so the way it is going to happen is I know that 60 degrees is the measure of that angle, but I also know there are 360 degrees in the whole circle. So if I wanted to think of it this way, what fraction of the whole circle is 60 degrees? Well, to do that, I would take 60 degrees and write as a fraction out of 360 and reduce that to figure out that this actually becomes 636. I can divide both those numbers by 10, and 6 and 36 actually both divide by 6. So that means that I really have 1/6 of the circle. In other words, the distance around this arc is 1/6 of the way around the whole thing. So one way I could do it is just to find the circumference. Remember, we learned that on Friday, or reviewed it on Friday. 2 pi times the radius, or pi times the diameter, gives you the whole distance around. And now, if I want to find what 1/6 of that is, I could just multiply 1/6 times the circumference, and I would get what part of it is this arc. Now, another way I like to think of it is just to rearrange this equation a little bit. They've got it written as the length of the arc, AB, for example, is to take the measurement of AB, which is in degrees, so that would be my 60 degrees, divided by 360 times the circumference. I'm just going to remember this is the circumference here. Okay, now I'm going to, in the rest of these examples today, I'm going to abbreviate this length of AB, or the length of the arc. I'm just going to abbreviate that with the letter L, length of the arc, for length of the arc. And they've got it written right now as L equals the measure of arc AB divided by 360 equals, or times, sorry, essentially the circumference, 2 pi r or pi d. I'm just going to always use pi d actually. Okay, because if we're given the radius, I'm just going to double it and find the diameter. Now, if I were to divide both sides by the circumference, we get a proportion. So I'm going to write this actually as the length of the arc divided by the circumference, pi d, is equal to the measure of the arc in degrees divided by 360. And that way, you know, we've been pretty good. We've practiced a lot of problems where we solve proportions and cross multiply, and I like to solve this problem this way too. So the thing I'm trying to find in all the examples is going to be the length of the arc. Pi times diameter represents the circumference. And over here we have the fraction made up of the central angle, or the arc measure, divided by the total number of degrees in a whole circle, which is 360. Let's skip ahead now and look at the first example problem. Okay, here we go. The picture in A, problem 4A, shows a circumference, or a circle where the diameter is 16 inches, and it wants to know the length of the arc shown in red. Well, I'm going to trace it out a little darker here. It's this arc right here. Okay, and the angle associated with that arc is this right angle, and let's go ahead and remember that that's 90 degrees there. So the way I wanted to do this that I showed in the last section was, let's take the ratio of that angle, 90, compared to the number of degrees in the whole circle, which is 360. And now I'm going to measure this, I'm going to label this arc, or I'm going to call it L for the length of that arc. And underneath that, I'm going to compare that to the circumference of the whole circle, which is pi times the diameter. And so the only thing I have to fill in is the diameter, which was 16 inches. And the thing I want to find is L. Okay, so we're going to fill this in one more time. 90 divided by 360 equals the length of the arc. And then since the diameter is 16, pi d is going to be 16 pi. Now the other thing I like to do right away is this fraction made up of the angle measures. I like to reduce that, so I notice that 90 and 360 easily divide by 10, which means I'm just going to get rid of the zeros, and it becomes 9 over 36. Now if you look carefully, 9 and 36 also both divide by 9, and so I can reduce this to 1 over 4. Makes the math way simpler now. So when I go to cross multiply, I'm multiplying L times 4, and then 16 pi is just going to multiply times 1. So to solve for L, it only takes that we divide by 4. So my final expression is L equals 16 pi divided by 4. And if I divide and we're trying to reduce this side, 16 can divide by 4 to make 4. So my final answer is just 4 pi for the length. And since this was in inches, it'll be 4 pi inches for the length of that arc. And part B will be very similar. We're looking at the arc in red, which goes around this way. And we're told that the measure in degrees is 240. So I want to find out what 240 3/60ths of this circumference is. So remember, on this side, we're going to call it the length of the arc, and here it's going to be pi d, the circumference of the circle. And I can tell from the picture that the radius was the 15. So if you think about that, if the radius is 15, the diameter is going to be 30. And so let's go ahead and fill this side in as 30 pi for the pi d. And over here, let's reduce this fraction. 240 and 360, again, both divide by 10. That knocks it down to 24 over 36. Now, I'd like you to think here, what can divide into both 24 and 36? Thinking about that, I know they can both divide by 12. So 24 divided by 12 makes 2. And 36 divided by 12 is 3. So this makes the ratio 2/3. In other words, this is 2/3 of the way around the circle. And now we have a much simpler equation to solve. Cross multiplying 3L equals 2 times 30 pi, which will be 60 pi. And now we're going to divide to solve for L. Divide by 3. Divide by 3. So L, the length of that arc will be 60 pi divided by 3. So you should try and reduce this too. And 60 can divide by 3 to make 20. So 60 divided by 3 is 20. So 20 pi. And then since the units are centimeters, the length of that arc is 20 pi centimeters. Notice we're not using the value 3.14 for pi. We're asked to leave it in terms of pi, which means the pi symbol stays in the answer. We've got one more problem to look at. This time there is no diagram, but it does say in words that we want to find the length of a semicircle where the radius of the semicircle is 1.3 meters. Once again, we're asked to leave our answer in terms of pi. Okay, well, let's actually draw a model of that circle. And a semicircle means that really this is half, right? We're finding the length of half of the circle. And since the radius was 1.3 meters, that would mean that the diameter would be double that. So 2.6 meters is the diameter all the way across. Once again, let's think about how many degrees this is then. And well, if that's a semicircle and 360 is the whole thing, 180 degrees is half. And so my equation starts off like this: 180 degrees out of 360 degrees is equal to the ratio of the length of the arc divided by pi times diameter, and pi times diameter is pi times 2.6. And this fraction of 180 over 360 immediately reduces down easily because it's exactly half of the circle. And so this represents the fraction 1/2. So my equation is 1/2 equals the arc length divided by 2.6 pi. Cross multiplying 2 times L equals 2.6 pi. And I'm going to divide both sides by 2. And over on this side, 2.6 divided by 2 is 1.3. So I can leave the answer as 1.3 pi meters. Well, guys, this is the last lesson for this section, and I hope you guys have a great Monday, and we have a good week together learning a little bit more about circles. The next section will be talking about areas of circles, and then the areas of partial circles. We'll be doing that on Wednesday and Friday. See you guys then.